This question says a truck driver traveling at 36 kilometers per hour. 36 kilometer per hour, dear student, is actually equal to 10 meter per second. Sees the traffic light turn red at an intersection. If its reaction time is 0.6 seconds and the truck retards at 6 meter per second square, then the distance traveled by the truck before stopping is something that we have to calculate. The total distance st will be equal to s1 plus s2, where s1 is the distance traveled with uniform speed. This will be equal to 10 into 0.6, and the distance traveled in retardation can be written as 10 square by 2 into 6, as the distance traveled with a speed u till it stops with acceleration or retardation a is equal to u square by 2a. So this will be equal to 6 plus 8.33, and that will be equal to 14.33 meters. Meaning that for this question the correct answer should be option number 4. Now moving on to the question number 22. Question 22 says, if a stone when released from rest travels half of its total path in the last second of its fall, then the height from which the body falls is nearly. The student, let the time of flight be t, so t can be written as under root of 2h by g, where h is the total height. It is given that in t minus 1 seconds, the distance traveled or the height traveled is h by 2, so t minus 1 will be equal to 2h by 2 by g into the power half. So this will be equal to under root h by g. If we subtract these two equations, we get a value that root h by g into root 2 minus 1 equal to 1, as root 2 is equal to 1.414 approximately. On solving this, we get a value of h to be approximately equal to 58 meters. And hence for this question, the correct answer turns out to be option number 3. Now let us move and solve the question number 23. Question 23 says, in a two-dimensional motion, instantaneous speed v0 is a positive constant. We have to find out that among the given options which is correct option. Now let us, for the sake of simplicity, take an example. Let us take an example of a uniform circular motion. The student, in a uniform circular motion, the speed, that is the magnitude of the instantaneous velocity, is constant. The velocity, however, changes direction at every instant. In this case, the acceleration, that is the centripetal acceleration, has a value of v square by r, where v is the speed. Here, the acceleration has a constant magnitude. However, it changes the direction at every instant. This means that acceleration of the particle is variable. It is not constant. However, it is in the plane of motion. And hence, for this question, the correct answer should be option number 3. Now let us move to the question number 24. In this question, which statement is true with respect to the projectile motion? The student, the acceleration due to gravity, which is downward, is a constant value, and it is the net acceleration in the projectile motion. Now, since it is vertically downwards, the horizontal component of the speed remains constant and remains unchanged. And hence, for this question, a simple analysis or the understanding gives us a correct answer, which is option number 1. Moving on to the question number 25. In this question, the angular speed of a fan makes 240 revolutions per minute. The student, RPM can be easily calculated and converted to radian per second. We have to do that here only. Now, x RPM is equal to x into 2 pi by 60 radian per second. So this will be equal to 240 into 2 pi by 60, and this will give us a value of 8 pi radian per second, meaning that for this question the correct answer should be option number 1.